In the early years of the Second World War, German armored forces dominated the battlefields of Europe with speed, precision, and advanced tactical coordination. The Blitzkrieg strategy had crushed Poland, overwhelmed France, and pushed deep into Soviet territory. German tanks, supported by well-trained crews and coordinated air power, seemed nearly unstoppable. Yet by 1942 and 1943, something began to change. A new machine appeared on the battlefield in ever-growing numbers, the American M4 Sherman tank. At first, German commanders did not consider the Sherman a serious threat. Reports described it as lightly armored and outgunned compared to Germany's formidable Panther and Tiger tanks. However, what concerned them was not the tank's individual strength, but its overwhelming presence. Shermans appeared everywhere, in North Africa, in Italy, and later across Western Europe. Destroy one, and another quickly took its place. The opportunity to study this mysterious advantage came when German forces captured several intact Sherman tanks. Some had been abandoned during rapid Allied advances, while others were recovered from damaged battlefields and carefully transported to German testing facilities. For German engineers and military analysts, these captured vehicles represented a rare chance to examine the technological and industrial capabilities of their enemy. One of the primary locations for such evaluations was the Kummersdorf Army Research Center south of Berlin. Here, German engineers and weapons specialists conducted detailed examinations of captured Allied equipment. When the first Sherman arrived, expectations among the German technical teams were modest. Many assumed they would confirm what they already believed, that the American tank was technically inferior to German designs. As engineers began their inspection, they carefully documented every detail. They measured the armor thickness, studied the turret design, and analyzed the internal mechanical layout. The Sherman's armor was not exceptionally thick, nor was its main gun the most powerful on the battlefield. Compared to the heavy armor and high-velocity guns of German Panther and Tiger tanks, the Sherman appeared unimpressive. But as the examination continued, the engineers noticed something unexpected. The internal layout of the Sherman was remarkably organized. Components were arranged in a way that allowed easy access for maintenance and repair. The engine compartment was spacious and designed for quick servicing. Parts could be removed and replaced without dismantling large sections of the vehicle. To German engineers, who were accustomed to highly complex and tightly packed machinery, this simplicity was surprising. The design reflected a different philosophy, one that prioritized reliability and efficiency over technical perfection. Further inspection revealed standardized components throughout the tank. Bolts, fittings, and mechanical parts followed consistent patterns. Many elements were interchangeable, meaning damaged components could be replaced quickly in the field. German engineers realized that this approach allowed American crews to repair their tanks rapidly, returning them to combat with minimal delay. The Sherman's transmission and suspension systems also drew attention. Though not revolutionary, they were robust and dependable. German reports noted that the vehicle was designed to function under a wide range of conditions, from the deserts of North Africa to the muddy terrain of Europe. It was not built to be the strongest tank, it was built to work consistently. Another striking discovery was the Sherman's manufacturing quality. Welds were clean and uniform. Cast components showed high consistency, suggesting advanced industrial production methods. German analysts began to understand that this tank was not merely a weapon, it was the product of a powerful industrial system capable of producing thousands of identical machines. This realization raised troubling questions. German tanks like the Panther and Tiger were engineering masterpieces, but they were also complicated, expensive, and time-consuming to produce. Each vehicle required significant resources and skilled labor. The Sherman, by contrast, appeared designed for mass production. Captured documents and battlefield intelligence reinforced this concern. American factories were producing Sherman tanks at a rate Germany could not hope to match.
Even if a Sherman was individually weaker, its constant presence on the battlefield created a strategic advantage. German test crews conducted driving trials with the captured vehicles. They found the Sherman easy to operate and mechanically reliable. The controls were straightforward, reducing the training time required for new crews. Its engine performed consistently during long tests, showing fewer mechanical failures than many German vehicles under similar conditions. For German engineers, the implications were becoming clear. The Sherman represented more than a single piece of equipment. It reflected an entirely different way of waging war. While Germany focused on technological superiority and complex engineering solutions, the United States emphasized reliability, standardization, and overwhelming production capacity. What began as a routine technical evaluation gradually turned into a moment of strategic insight. The captured Sherman forced German analysts to confront a harsh reality. They were not merely fighting enemy tanks, but an industrial power capable of replacing losses faster than Germany could destroy them. By the end of the initial examinations, German engineers submitted detailed reports to the High Command. Their findings did not praise the Sherman as the most powerful tank on the battlefield. Instead, they emphasized its reliability, ease of production, and logistical efficiency. These qualities, they warned, posed far greater threat than armor thickness or gun size. The captured Sherman had revealed something deeply unsettling, a glimpse into the future of modern warfare, and what German engineers saw there would challenge everything they believed about victory.
Following the initial inspection of the captured Sherman, German engineers moved from general observations to a deeper technical analysis. What they discovered inside the American tank challenged many of their assumptions about armored warfare and engineering philosophy. The Sherman was not designed to dominate through complexity or superior firepower. Instead, it represented a radically different approach, one that emphasized simplicity, reliability, and efficiency. German tank design had long followed a philosophy of technical superiority. Vehicles such as the Panther and Tiger were built with powerful high-velocity guns, thick armor, and advanced targeting optics. These machines were engineering achievements, representing the peak of German industrial capability. However, this sophistication came at a cost. German tanks were mechanically complex, difficult to maintain, and required highly skilled crews and technicians to keep them operational. As German engineers dismantled the Sherman piece by piece, they immediately noticed the contrast. The interior of the Sherman was spacious and logically organized. Critical components such as the engine, transmission, and fuel systems were positioned for easy access. Panels could be removed quickly, allowing mechanics to perform repairs without extensive disassembly. In German tanks, similar maintenance often required hours of labor and specialized tools. The Sherman, by comparison, appeared almost modular in its construction. The American tank used a design philosophy that prioritized field maintenance. Engineers observed that many components could be replaced by ordinary mechanics with basic training. This meant damaged vehicles could be repaired close to the front lines rather than being transported back to specialized facilities. For an army engaged in global warfare across multiple continents, this advantage was enormous. One of the most striking features was the Sherman's use of standardized parts. German analysts noted that identical components were used across large numbers of vehicles, allowing spare parts to be distributed efficiently. Bolts, bearings, and mechanical fittings followed uniform specifications. This level of standardization reduced manufacturing time and simplified logistics. In contrast, German tank production often involved small variations between models and production batches. Even minor design changes could require different replacement parts, complicating repairs and supply chains. The Sherman's uniformity represented an industrial system focused on consistency rather than constant redesign. The Sherman's engine design also attracted close attention.
Various Sherman models used different engines, including the radial aircraft-style engine and later multi-bank configurations, but all were designed for durability and ease of maintenance. German engineers tested the engine under extended conditions and found it dependable and relatively easy to service. Although the engine did not deliver the raw power of some German designs, it proved reliable during prolonged operation. This reliability meant fewer mechanical failures in combat situations. German engineers understood that a tank unable to move or fight due to mechanical breakdown was effectively useless, regardless of its armor or weapon strength. The suspension system further demonstrated American priorities. The Sherman's vertical volute spring suspension was simple and robust. It allowed the tank to move effectively across uneven terrain while remaining relatively easy to repair. German suspension systems, while often technologically advanced, were complex and prone to difficulties, especially in harsh environments such as the Eastern Front's mud and freezing temperatures. German testing also examined the Sherman's turret design and crew layout. The interior provided adequate space for crew members to operate efficiently, reducing fatigue during long engagements. Controls were straightforward, instruments were clearly arranged, and communication systems were practical and effective. These features improved crew performance and reduced training requirements. German engineers noted that American designers appeared to consider the human factor as carefully as the machine itself. The Sherman was not merely a weapon, but a system designed for continuous operation by ordinary soldiers. Perhaps the most surprising discovery was the Sherman's manufacturing approach. The tank incorporated both welded and cast components produced with remarkable consistency. German inspectors observed high production quality despite the tank's relatively simple design. The manufacturing process appeared optimized for speed without sacrificing reliability. This reflected the strength of American industrial organization. Instead of crafting highly specialized machines in limited numbers, the United States produced standardized equipment on massive scale. The Sherman was designed from the beginning to be built quickly, repaired easily, and deployed globally. For German engineers, the contrast was striking. Germany pursued technological excellence through complexity and precision engineering. The United States pursued victory through reliability, efficiency, and production volume. As their analysis continued, German specialists began to recognize the broader implications. The Sherman's simplicity was not a weakness, it was a deliberate strategic choice. By sacrificing certain aspects of performance, American designers achieved a level of reliability and production efficiency that Germany struggled to match. Reports from the Eastern Front had already revealed frequent mechanical failures among German armored units, particularly with the Panther tank during its early deployment. Many vehicles broke down before reaching the battlefield. The Sherman, by comparison, was designed to endure long marches and continuous operation with minimal maintenance. This difference represented more than engineering preference. It reflected two opposing visions of modern warfare. German strategy relied on technological superiority and highly trained specialists. American strategy relied on industrial strength, logistical efficiency, and dependable equipment. By the conclusion of their technical evaluation, German engineers understood that the Sherman embodied a powerful principle of industrial warfare. A weapon that works every time can be more valuable than one that is superior only under ideal conditions. The captured Sherman revealed a reality that German planners found increasingly difficult to ignore. While Germany built some of the most advanced tanks in the world, the United States was building tanks that could be produced faster, repaired easier, and deployed in overwhelming numbers. Inside the Sherman, German engineers had discovered not just mechanical components, but a philosophy of war that threatened to outmatch their own.
As German engineers completed their technical analysis of the captured Sherman, their attention shifted from the tank's design to an even more troubling question. How was the United States producing so many of them? The answer, they soon realized, revealed a strategic advantage far greater than any individual weapon. By 1942, the Sherman tank was appearing in increasing numbers across multiple fronts. In North Africa, German forces encountered entire formations of American-built armored vehicles supporting British troops. In Italy, Shermans arrived continuously despite heavy losses. Later, following the Allied landings in Normandy, German commanders reported an overwhelming presence of these tanks advancing across Western Europe. To German planners, this raised a critical concern. Germany's own tank production struggled to keep pace with battlefield losses. Complex machines such as the Panther and Tiger required significant time, skilled labor, and scarce materials to manufacture. Even minor disruptions in supply chains could delay production for weeks or months. The Sherman, however, seemed to be everywhere. German intelligence began gathering information on American industrial output. What they discovered was staggering. The United States had transformed its entire economy into a vast war production system. Civilian factories were converted to military manufacturing. Automobile companies, which had once produced passenger vehicles, now built tanks, engines, and armored vehicles on assembly lines operating day and night. Companies such as Ford, General Motors, and Chrysler played central roles in this transformation. The famous Ford River Rouge plant applied automotive assembly line techniques to tank production, dramatically increasing efficiency. Instead of constructing each vehicle individually, American factories produced standardized components in enormous quantities, which were then assembled rapidly. German analysts studying documents and intelligence reports were astonished by the scale. Thousands of Sherman tanks were being produced every month. Losses in combat, which would have severely weakened German armored units, were quickly replaced by fresh shipments from across the Atlantic. This level of production created a new kind of battlefield reality. For Germany, every destroyed tank represented a significant loss of resources and time. For the United States, a destroyed Sherman was simply one of many, easily replaced. German engineers also examined the Sherman's manufacturing process itself. The tank's design supported rapid production. Large cast sections reduced the need for complex welding. Standardized parts allowed different factories to produce identical components. This meant production could be distributed across multiple facilities, increasing speed and reducing vulnerability to disruption. Germany's production system operated very differently. Many German tanks were built in smaller numbers using specialized methods. Design changes were introduced frequently, often improving performance but disrupting manufacturing efficiency. Each modification required adjustments to production lines, new parts, and additional training for workers. The result was a system that produced highly advanced machines but in limited quantities. The American approach prioritized consistency over constant innovation. Once the Sherman design was established, production focused on efficiency and reliability. Improvements were introduced gradually, without interrupting large-scale manufacturing. This stability allowed factories to achieve unprecedented output. Logistics further amplified this advantage. The United States possessed enormous shipping capacity, allowing thousands of vehicles to be transported overseas. Even after crossing vast oceans, Shermans arrived with spare parts, maintenance equipment, and trained support personnel. Entire logistical networks ensured that damaged vehicles could be repaired quickly or replaced entirely. German engineers recognized that this system extended far beyond the tank itself. It represented a coordinated strategy combining industry, transportation, and battlefield support. The Sherman was only one element of a massive war machine driven by economic power. Reports from the front confirmed these observations. German commanders frequently noted that Allied armored units maintained operational strength even after intense combat. While German units struggled to repair or replace damaged vehicles, Allied forces returned to battle with renewed strength. This imbalance gradually shifted the nature of warfare. German tactical victories became less decisive because they could not significantly reduce Allied strength.
Destroying dozens of Shermans in a single engagement did little to slow the overall advance. For German planners, this realization was deeply unsettling. Their military strategy had long emphasized superior technology and battlefield skill. Yet these advantages were being overshadowed by industrial capacity. The ability to produce and sustain large numbers of reliable machines was proving more influential than technical superiority alone. Economic data reinforced these concerns. The industrial output of the United States exceeded that of Germany by a vast margin. American factories produced not only tanks, but also aircraft, trucks, artillery, and ammunition in enormous quantities. This production capacity allowed the Allies to fight a prolonged war of attrition, a type of conflict Germany was poorly equipped to win. Some German officials began to understand that the war had become a contest of industrial systems rather than individual weapons. The Sherman symbolized this transformation. It was not the most powerful tank on the battlefield, but it represented the strength of a nation capable of producing thousands more. The implications extended beyond technology. American production demonstrated the effectiveness of total economic mobilization. Civilian industry, scientific research, and military planning were fully integrated into a unified war effort. Every factory, worker, and resource contributed to sustained military power. By late 1943 and 1944, the consequences were visible across all fronts. Allied forces advanced steadily despite heavy losses. German forces, though often fighting with superior equipment, faced growing shortages of vehicles, fuel, and spare parts. The captured Sherman had revealed a harsh truth. Germany was not simply confronting an opposing army, it was confronting an industrial giant whose productive capacity seemed limitless. For German engineers who had once focused solely on technical excellence, this realization marked a profound shift in understanding. The true strength of the Sherman did not lie in its armor or weaponry, but in the system that produced it. Industrial power had become the decisive weapon of modern warfare, and in this domain, Germany faced an opponent it could not match.
While German engineers studied the Sherman's design and production methods, another question demanded careful investigation. How did the tank actually perform in combat? Technical specifications alone could not explain its growing presence on the battlefield. To understand the Sherman's true impact, German analysts examined battlefield reports, conducted operational tests, and gathered testimonies from frontline soldiers who had faced the American tank in combat. What they discovered reinforced a conclusion that was becoming increasingly difficult to ignore. The Sherman's greatest strength was its reliability. German armored doctrine had traditionally emphasized superior firepower and heavy protection. Tanks like the Tiger and Panther possessed powerful guns capable of destroying enemy vehicles at long range, and their thick armor offered strong defensive capabilities. On paper, these machines far exceeded the Sherman in technical performance. Yet war was not fought on paper. On the battlefield, mechanical reliability often determined success or failure. German reports from the Eastern Front had already revealed serious problems with their advanced tanks. The Panther, introduced with great expectations, initially suffered from frequent engine failures, transmission breakdowns, and mechanical fires. Many vehicles became inoperable before even reaching combat zones. The Tiger, although formidable in combat, required constant maintenance. Its complex engineering demanded skilled technicians and regular servicing. In harsh conditions, mud, dust, extreme cold, mechanical failures were common. Recovery of damaged or disabled heavy tanks was difficult, often requiring specialized equipment and additional vehicles. In contrast, the Sherman demonstrated consistent operational performance. German test crews who operated captured Shermans reported that the tank started reliably even after long periods of inactivity. Its engine performed steadily under extended use, and its mechanical systems showed fewer failures during testing.
The vehicle could travel long distances without significant maintenance, a critical advantage in fast-moving operations. This reliability translated directly into battlefield effectiveness. Allied armored units equipped with Shermans were able to maintain continuous pressure during offensives. While German units frequently paused to repair or service their vehicles, Sherman formations continued advancing. Mobility was another key factor. The Sherman's design provided good speed and maneuverability across various types of terrain. Its suspension system allowed stable movement over rough ground, and its relatively moderate weight reduced the risk of becoming trapped in mud or damaging bridges. German heavy tanks, particularly the Tiger, often faced restrictions due to their weight and fuel consumption. German soldiers reported that Shermans frequently appeared in areas where heavy German tanks could not easily operate. Their mobility allowed them to exploit weaknesses, flank defensive positions, and maintain operational flexibility. Another important aspect was crew survivability. Although early Sherman models gained a reputation for catching fire when penetrated, leading German crews to nickname them Tommy Cookers, American engineers introduced improvements such as wet ammunition storage, which significantly reduced fire risk. Later battlefield reports indicated improved survival rates for Sherman crews. German analysts recognized that preserving trained personnel was essential. A tank could be replaced, but experienced crews required time and resources to train. The Sherman's design, which emphasized crew safety and escape mechanisms, helped maintain Allied operational strength over time. Ease of operation also contributed to battlefield success. The Sherman's controls were straightforward, allowing crews with relatively limited training to operate the vehicle effectively. German tanks, by comparison, required highly skilled operators due to their complex systems. As the war progressed and Germany faced shortages of experienced personnel, this difference became increasingly significant. Communication systems further enhanced the Sherman's effectiveness. American tanks were equipped with reliable radio equipment, a standard issue, enabling coordinated movement and rapid response to changing battlefield conditions. German units, particularly earlier in the war, did not always equip every vehicle with equivalent communication systems. This advantage allowed Allied units to coordinate attacks, request support, and adapt quickly. The Sherman was not merely a machine, but part of a larger operational network that enhanced overall combat effectiveness. Fuel efficiency and maintenance requirements also played decisive roles. The Sherman consumed less fuel than many German heavy tanks, allowing longer operational range and reducing logistical strain. Its simpler design required fewer spare parts and less specialized maintenance, enabling sustained operations even in challenging conditions. German field reports repeatedly described a frustrating pattern. Even when German tanks achieved tactical superiority in individual engagements, Allied forces returned with renewed strength. Shermans that had been damaged were quickly repaired or replaced. Their operational availability remained consistently high. This constant presence gradually shifted the balance of power. German crews, despite operating technically superior machines, found themselves facing an enemy that could maintain numerical and operational advantage over extended periods. German testing of captured Shermans confirmed what battlefield experience had already suggested. The tank was not designed to win through individual dominance, but through dependable performance under all conditions. It functioned effectively in heat, cold, mud, and dust. It required minimal maintenance and remained operational even after extensive use. For German engineers trained to pursue technical perfection, this approach represented a different form of strength. A weapon that consistently worked in real conditions could prove more valuable than one that excelled only under ideal circumstances. By 1944, the consequences were visible across multiple fronts. German armored units increasingly faced shortages of operational vehicles, while Allied formations maintained steady strength. Mechanical breakdowns, fuel shortages, and logistical difficulties limited German effectiveness even before battle began. The Sherman's battlefield performance revealed a fundamental truth of modern warfare. Victory depended not only on superior weapons, but on reliable systems capable of sustained operation. The lessons drawn from the captured Sherman and battlefield observations were becoming undeniable. Reliability, mobility, and logistical efficiency were reshaping the nature of armored warfare. And as German analysts would soon conclude, these qualities reflected a broader strategic advantage that extended far beyond the battlefield.
By the time German engineers completed their examinations of the captured Sherman tanks, the technical conclusions were clear. The American vehicle was not superior in armor thickness. It did not possess the most powerful gun. It was not the most advanced machine on the battlefield. And yet, it kept coming. What began as a technical investigation had evolved into something much deeper, a strategic revelation. Reports compiled from Kummersdorf and other testing facilities were forwarded to higher military authorities. The tone of these documents was professional and analytical, but beneath the technical language lay a growing sense of concern. The Sherman represented more than a tank. It was the visible expression of an industrial system operating at full capacity. German planners had long believed that technological excellence would compensate for material limitations. Their armored doctrine was built around the idea that fewer, superior tanks could defeat larger numbers of inferior ones. Early successes in Poland, France, and the early stages of Operation Barbarossa appeared to validate this belief. But by 1943 and 1944, the strategic situation had changed dramatically. On the Eastern Front, the Soviet Union was producing thousands of T-34 tanks, applying similar principles of simplicity and mass production. In the West, the United States was manufacturing Shermans in overwhelming numbers. Germany now faced two industrial giants capable of sustaining prolonged warfare. The captured Sherman forced German analysts to confront an uncomfortable truth. The war had become a contest of economies. American factories were not merely replacing battlefield losses, they were expanding Allied armored strength continuously. Even heavy German losses inflicted during defensive battles did little to slow the overall momentum of Allied forces. Destroyed Shermans were replaced within weeks. New units arrived with fresh vehicles and trained crews. Meanwhile, Germany's industrial base was under increasing strain. Allied strategic bombing campaigns targeted factories, railways, and fuel production facilities. Shortages of raw materials became more severe. Skilled labor was limited. Complex tanks like the Panther and Tiger required large quantities of steel, precision components, and specialized manufacturing time. Every German tank destroyed represented a serious blow. Replacement was neither quick nor guaranteed. The realization extended beyond tank production. American industry produced vast numbers of trucks, enabling rapid movement of troops and supplies. It delivered enormous quantities of fuel, ammunition, aircraft, and artillery. The Sherman was simply one visible element of a much larger system of coordinated production and logistics. German engineers began to understand that their focus on technical superiority had overlooked a crucial factor: sustainability. A weapon, no matter how advanced, was ineffective if it could not be produced and maintained in sufficient numbers. The Sherman embodied a philosophy of total war mobilization. American industry had been fully integrated into the war effort. Civilian factories shifted to military production with remarkable speed. Standardized designs minimized disruption. Continuous production lines operated day and night. In contrast, Germany's production system was fragmented for much of the war. Competing priorities, political interference, and frequent design modifications slowed efficiency. Only later, under the direction of Albert Speer, did German production become more centralized and streamlined, but by then the industrial gap had grown too large.
German field commanders reported increasing difficulty maintaining operational strength. Fuel shortages immobilized armored units. Spare parts became scarce. Even when advanced tanks were available, they could not always be deployed effectively. Meanwhile, Allied forces demonstrated growing operational coordination. Shermans supported infantry advances, worked alongside artillery, and operated under air superiority provided by thousands of Allied aircraft. The industrial advantage translated directly into combined arms effectiveness. By late 1944, during battles such as the Ardennes Offensive, Germany attempted one final large-scale counterattack in the West. Despite initial success, the offensive stalled. Fuel shortages, mechanical breakdowns, and overwhelming Allied response halted German momentum. The industrial imbalance made sustained offensive operations impossible. For the engineers who had studied the captured Sherman months earlier, the broader picture was now unmistakable. The tank symbolized a strategic reality that could no longer be ignored. The war was no longer determined by isolated tactical victories or superior engineering feats. It was determined by the capacity to produce, replace, and sustain. The Sherman's strength lay not in its armor or firepower, but in its reliability, its manufacturability, and the industrial power behind it. It was designed not to win a single battle decisively, but to contribute to a continuous, unstoppable pressure across multiple fronts. German engineers trained to perfect complex machines found themselves confronting a different kind of superiority, one rooted in economic scale and organizational efficiency. In retrospect, the captured Sherman represented a warning. It revealed that Germany was facing opponents whose resources, industrial capacity, and logistical systems far exceeded its own. Even the most advanced German tanks could not compensate for shortages of fuel, materials, and production volume. By early 1945, as Allied forces advanced from both east and west, the outcome was clear. German armored units fought with determination, but they could not match the sustained strength of their adversaries. The examination of a single captured Sherman had provided a glimpse into this future. It demonstrated that modern warfare required more than technological brilliance. It required the ability to mobilize entire nations, factories, workers, transportation networks into a unified system of continuous production. In the end, the lesson was stark and unavoidable. Germany was not defeated solely by superior tanks. It was defeated by an industrial and logistical force that it could never equal. The Sherman revealed the true battlefield, and it stretched far beyond the front lines.